Off the coast of Florida, History Channel divers were looking for the remains of World War II aircraft. Instead, they came across a 20-foot relic from one of America's saddest days.
The call came through to Naval Station Mayport just after dawn on a Tuesday morning in late October. A specialized dive team, one trained for deep water recovery and equipped with the latest sonar technology, was being deployed to coordinates they recognized immediately. 3 miles off Cape Canaveral, in 120 feet of dark Atlantic water, lies the final resting place of Space Shuttle Challenger. The wreckage has been there since 1986, mostly undisturbed except for the initial recovery operations that brought back what could be salvaged. But something had changed. Satellite monitoring had detected unusual activity in the area, and the Navy needed to know what was happening down there. What the divers discovered when they activated their sonar has remained partially classified, but enough information has leaked through official channels and unofficial sources to paint a picture that's both fascinating and deeply disturbing. This isn't just about old wreckage sitting on the ocean floor. This is about something that nobody predicted, something that challenges our understanding of what happens to these artifacts when we leave them in the deep. January 28, 1986. That date is burned into the memory of anyone old enough to remember it. 73 seconds after launch, Challenger disintegrated in the sky above Cape Canaveral, taking 7 astronauts with it. Commander Francis Scobie, pilot Michael Smith, mission specialists Judith Resnick, Ellison Onizuka, and Ronald McNair, payload specialist Gregory Jarvis, and teacher Krista McAuliffe all perished in an instant that shocked the world. The shuttle broke apart at an altitude of 46,000 feet, traveling at nearly twice the speed of sound. The debris rained down across the Atlantic, some pieces hitting the water within seconds, others following ballistic arcs that carried them miles away. The crew cabin, essentially intact but fatally damaged, plunged into the ocean at over 200 miles per hour. The impact was catastrophic. Recovery operations began immediately and continued for months. Navy ships and divers worked tirelessly to bring back pieces of the shuttle, mapping the debris field and trying to understand exactly what had happened. They recovered the crew cabin. They found the solid rocket boosters. They brought back thousands of fragments, large and small, each one cataloged and studied as part of the investigation that would eventually reveal the O-ring failure responsible for the disaster. But they didn't recover everything. Large sections of the shuttle remained on the ocean floor, deemed either too difficult to retrieve or too damaged to provide useful information. The decision was made to leave much of the wreckage where it fell, creating an unintentional underwater memorial to the crew and the mission that failed so spectacularly. For nearly 4 decades, that wreckage has rested in the darkness. The Atlantic is not a gentle environment. Currents scour the debris. Salt water corrodes metal. Marine life colonizes every surface. But the wreckage endures, a scattered field of aluminum, titanium, and composite materials that once represented the cutting edge of aerospace engineering. The Navy's decision to return to the site wasn't made lightly. Official statements cite routine monitoring and environmental assessment, but sources within the Naval Sea Systems Command tell a different story. Apparently, acoustic sensors positioned along the Atlantic coast as part of submarine detection networks had been picking up unusual sounds from the Challenger site. These weren't the normal pings and groans of metal settling or shifting in currents. These were structured, repetitive signals that didn't match any known natural or man-made source. The dive team that deployed in October was equipped with side-scan sonar, capable of creating 3-dimensional maps of the ocean floor with extraordinary detail. They also carried magnetometers to detect metallic objects and acoustic sensors to record any sounds emanating from the wreckage. The mission plan called for a systematic survey of the entire debris field, something that hadn't been done comprehensively since the 1980s. What they found defied expectations. The sonar images showed the expected scatter pattern of debris, but they also revealed something that shouldn't have been there. Beneath the largest sections of wreckage, the ocean floor showed signs of subsidence, of sinking. The wreckage wasn't just sitting on the seabed anymore, it was being swallowed by it. Further analysis revealed cavities beneath the debris field, voids in the sediment that suggested the weight of the wreckage was causing the seafloor to collapse in localized areas. Some of these voids were substantial, large enough to potentially consume entire sections of the shuttle if the overlying sediment gave way completely. This was geological activity that nobody had predicted or modeled when the decision was made to leave the wreckage in place. But the subsidence wasn't the most disturbing discovery. The sonar also detected what divers are describing as anomalous structures within the debris field. These aren't pieces of the shuttle. They're formations, accretions of material that have grown around and between the wreckage over the decades. Some of these formations are massive, several times larger than the debris they've enveloped. Marine biologists consulted about the findings initially suggested coral growth or similar biological encrustation, but the structures don't match known patterns of coral development. They're too geometric, too regular. Some researchers are now theorizing that the combination of aerospace materials, particularly exotic alloys and composites used in shuttle construction, may be interacting with the marine environment in unexpected ways, catalyzing mineral deposition or biological growth that wouldn't normally occur. There's also the question of what the sonar couldn't penetrate. Several sections of the debris field returned only partial echoes, suggesting either extremely dense material or some kind of acoustic absorption that prevents the sonar from mapping what's beneath. This is particularly pronounced around what divers believe is the main engine section, a massive piece of wreckage that contains some of the shuttle's most robust components. The acoustic signatures that prompted the dive mission in the first place have continued during the survey. Hydrophones positioned around the site recorded sounds that technicians describe as resonance, as if the wreckage itself is vibrating at specific frequencies. Some of these sounds fall below the range of human hearing, deep bass frequencies that require specialized equipment to detect. Others are well within the audible spectrum, metallic groans and what some divers insist sound almost like whale song, though no whales were detected in the area. One theory gaining traction among the dive team is that the hollow structures within the wreckage, pressurized tanks, sealed compartments, engine bells, are responding to current flows and pressure changes, essentially turning portions of the debris field into massive underwater instruments. The ocean itself plays these instruments, creating the haunting sounds that sensors have been detecting. But there's another concern that nobody wants to discuss publicly, but everyone involved is thinking about. The crew cabin was recovered in 1986, but the recovery wasn't complete. Certain elements, certain remains, were left behind, either because they couldn't be located or because the condition made recovery impossible or inadvisable. The possibility that the sonar has detected evidence of those remains, now encrusted or buried beneath decades of sediment and growth, is something that weighs heavily on everyone connected to the mission. The families of the Challenger crew were notified before the dive mission commenced. Some expressed support for the survey, wanting to ensure the site is being properly monitored and protected. Others questioned why the wreckage couldn't simply be left alone, why this underwater grave had to be disturbed after so many years. It's a valid question without an easy answer. From a practical standpoint, the environmental concerns are real. The shuttle was built using materials that weren't designed for long-term ocean exposure. Toxic compounds, heavy metals, residual propellants. All of these are potentially leaching into the marine environment. Some environmental scientists argue that the wreckage should be recovered entirely, removed from the ocean before it causes more contamination. Others counter that the act of recovery would disturb the sediment and release far more pollutants than slow natural degradation. The sonar data has revealed that some sections of wreckage are in far worse condition than anyone expected. Structural members that should have lasted centuries are showing advanced corrosion. Composite materials are delaminating. In some areas, what appears as solid debris on the surface is actually just a shell, the interior completely hollowed out by corrosion and biological activity. This degradation raises urgent questions about other wreckage sites, not just in the ocean, but anywhere spacecraft debris has been left to the elements. If Challenger is deteriorating this rapidly, what about other sites? What about the debris fields from other space disasters? The Navy's survey also detected something that has nothing to do with Challenger, but everything to do with the ocean itself. The seafloor in this area is not stable. Sediment flows, underwater landslides on a scale too small to register on most monitoring equipment, but large enough to shift debris, are constantly reshaping the bottom. The Challenger wreckage is slowly migrating, moving fractionally with each current, each storm, each shift in the sediment beneath it. Over decades, this migration has carried some pieces of the wreckage far from their original impact points. The debris field is spreading, diffusing across a wider and wider area. At the current rate, sonar operators estimate that within another 50 years, the wreckage will be scattered over an area 10 times its current size, making any comprehensive survey or recovery effectively impossible. There are pieces of Challenger that the sonar located more than a mile from the main debris field. Small fragments, carried by currents or buried and then exposed by shifting sand, now lie isolated on the seafloor. Some of these fragments are identifiable, sections of wing, pieces of the payload bay. Others are simply twisted metal, unrecognizable without extensive analysis. The most haunting aspect of the sonar data is how it captures the violence of what happened. The debris field isn't random. It tells a story. You can see the impact points, the way pieces hit the water and drove into the seabed. You can trace the trajectories. You can see where the crew cabin came to rest and how the force of impact created a crater that still hasn't fully filled in after nearly 40 years. Advanced imaging has allowed operators to create fly-through animations of the debris field, virtual dives through the wreckage based on sonar data. Watching these animations, seeing the scale and the devastation rendered in ghostly three-dimensional detail, brings home the reality of what happened in a way that surface-level knowledge never could. This was a disaster of enormous proportions, and the evidence of that disaster remains, waiting in the darkness. The question now facing the Navy, NASA, and other government agencies is what to do with this information. The sonar data is extraordinarily detailed, revealing aspects of the wreckage that were unknown or poorly documented during the original recovery. Some of this data could be valuable for historical purposes, for understanding exactly how the shuttle broke apart and how debris behaves in ocean impact scenarios. But releasing the data publicly means releasing images and information that could be deeply distressing to the families of the crew and to the public that still mourns Challenger. There's also the matter of what the ongoing investigation might reveal. The dive team's work isn't finished. Additional surveys are planned, potentially including ROV deployments and even limited physical sampling of the anomalous structures detected by sonar. Each new piece of data could answer questions, but will certainly raise new ones. Some within the Navy are pushing for a comprehensive recovery operation, arguing that the wreckage represents both a historical artifact that should be preserved and an environmental hazard that should be removed. The cost would be enormous, potentially exceeding $100 million for a full recovery, but the symbolic and practical value might justify the expense. Others argue for a different approach. Leave the wreckage where it is, but designate the area as a protected site, an underwater memorial that's monitored but not disturbed. Install permanent sensors to track environmental conditions and structural degradation. Create a comprehensive digital archive of the site using the most advanced scanning technology available, preserving a detailed record even as the physical wreckage continues to decay. What everyone agrees on is that doing nothing is no longer an option. The sonar data has revealed that the Challenger site is not static, not stable, not a simple memorial resting peacefully on the seafloor. It's an active site, changing, degrading, potentially hazardous, and definitely more complex than anyone imagined when the decision was made decades ago to leave it undisturbed. The families deserve to know what's been found. The public, which mourned Challenger and still remembers where they were when it happened, deserves transparency about what's happening to this piece of history. But that transparency has to be balanced against respect, against the understanding that this isn't just a debris field, it's a grave. In the weeks since the dive team returned to the surface, analysis of the sonar data has continued. New details emerge daily. New questions arise. The acoustic signatures continue. The subsidence continues. The ocean continues its slow work of transforming the wreckage into something that's no longer quite recognizable as a spacecraft. Navy divers will return to the site. More surveys will be conducted. More data will be collected. But the fundamental question raised by what the sonar detected remains unanswered. How long can we leave these artifacts in the ocean? How long before degradation, migration, and natural processes erase them entirely? And when that happens, what will we have lost beyond just metal and composite materials? The sonar images show a wreckage field that's becoming part of the ocean itself, colonized by life, buried by sediment, transformed by time and salt water and pressure into something that's neither fully spacecraft nor fully natural formation. It's a hybrid, a testament to both human ambition and the power of nature to reclaim what we leave behind. What the Navy divers found at the Challenger site is horrifying, not because it's grotesque or shocking in the conventional sense, but because it forces us to confront the impermanence of everything we build, everything we achieve, everything we leave behind. The ocean is patient and powerful, and given enough time, it erases all evidence that we were ever there at all. Challenger is being erased, slowly but inevitably, and the sonar data is a snapshot of that erasure in progress, a moment frozen in time before the ocean finishes its work, and the wreckage disappears entirely into the dark sediment of the Atlantic floor, lost forever except in memory and in the haunting images captured by machines that can see what human eyes cannot. The divers who witnessed the sonar data firsthand speak carefully about what they saw, constrained by classification protocols and by something else, a reluctance to put into words images that defy easy description. Off the record, one team member described sections of the wreckage as being consumed by the sea floor, not just resting on it, but actively being pulled down into sediment that appears to be behaving more like quicksand than stable ocean bottom. The visual is unsettling. The idea that Challenger isn't just deteriorating, but being swallowed whole by the Earth itself. There are psychological dimensions to this discovery that go beyond the technical and scientific. The generation that watched Challenger explode has lived for nearly 40 years, with a certain narrative about what happened and where the evidence of that tragedy rests. The sonar data disrupts that narrative. It suggests that the memorial site people imagine, a quiet resting place beneath the waves, is actually a scene of ongoing destruction, of continued violence enacted not by explosions or fire, but by the patient, relentless forces of geology and ocean chemistry. Comparisons are being drawn to other underwater wreck sites, particularly shipwrecks from world wars that have been monitored over decades. Many of those wrecks are collapsing at accelerating rates, the metal fatigued beyond its structural limits, the physics of corrosion reaching critical thresholds where entire vessels can collapse in moments. Titanic is perhaps the most famous example, deteriorating so rapidly that some researchers estimate it will be completely unrecognizable within another generation. Challenger may be following a similar trajectory, but compressed into a much shorter time frame because of the exotic materials involved and the violence of its initial impact. What makes the Challenger situation unique is the spacecraft materials involved. Unlike ships built from conventional steel, the shuttle incorporated titanium, specialized aluminum alloys, carbon composites, and materials designed for the extreme environment of space, not for prolonged ocean immersion. How these materials interact with seawater over decades wasn't extensively studied, because nobody planned for shuttles to spend 40 years on the ocean floor. The sonar data suggests these interactions are producing unexpected results, some of which may have implications for future spacecraft design and for how we think about the eventual disposal of space hardware. The investigation continues in classified briefing rooms and research facilities where the full sonar data is being analyzed frame by frame, anomaly by anomaly. What else will be discovered remains unknown, but the precedent has been set. Challenger is not resting peacefully, and what the Navy found suggests that our assumptions about what happens to our technological artifacts when we abandon them to the ocean need serious reconsideration. The most troubling aspect of the sonar findings may be what they imply about time itself and our relationship to historical events. For decades, Challenger existed in a kind of suspended state in the public consciousness, frozen at that moment of tragedy but somehow preserved, unchanging beneath the waves. The sonar data shatters that illusion completely. Time has been working on the wreckage every second of every day since it fell, transforming it in ways both predictable and utterly unexpected. When the next generation asks about Challenger, when students decades from now learn about the disaster in history classes, the physical evidence may no longer exist in any meaningful form. The ocean will have finished its work. The debris field will have migrated, collapsed, been buried so deeply that recovery becomes impossible. All that will remain are photographs, videos, data files, and memories growing fainter with each passing year. The sonar images captured during this recent dive may represent the last detailed documentation of Challenger as an identifiable spacecraft rather than as an abstract collection of corroded fragments scattered across an ever-widening area of seafloor.